All right, hey, good morning, everybody. Let's take a look at your FRQs here today for Chapter 8. This question's coming from the 2013 exam. So I apologize that my question here is very blurry. Hopefully you have a nice copy of it in front of you. Either you downloaded it from the Moodle site or you still had a copy of it from when I handed these out in class about a week or two ago. So actually, probably by the time you're watching this video, about 3 weeks ago. Anyway, let me just kind of read through the problem with you and then start answering these questions. So question 1 here says, an environmental group conducted a study to determine whether crows in a certain region were ingesting food containing unhealthy levels of lead. A biologist classified lead levels greater than 0.6 parts per million as unhealthy. The lead levels of a random sample of 23 crows in the region were measured and recorded. The data are shown in the stem plot. It's kind of nice, you got a nice stem plot. So question A is, what is the proportion of crows in the sample had lead levels that are classified by the biologists as unhealthy? Okay? So in this particular case, again, I got to go back. It says the lead levels it says a biologist classified lead levels greater than 6.0 parts per million as unhealthy. So that's stating it right here. I know it's a little bit fuzzy to read. So it says, what proportion of crows in the sample had lead levels that are classified as unhealthy? So this one here is really a very simple, if you want to kind of know what chapter is coming from, or it's really, how do you calculate out a proportion? I would consider it still falling under chapter 2 and really chapter 1, since you're looking at reading a stem plot. So looking at this, okay, I look at how I read this. Notice how this says 2, in their key it says 2.8 parts per million. So again, this is the whole number, this is the decimal place. So it's important to be able to read those. So any, okay, that is, as again said, greater than 6. So I'm looking for, values. So if I want to think about this, values that are greater than 6.0. So this is going to kind of go to part A. So that proportion, my proportion in our case here is as simple as saying 4 divided by 23. So on my calculator, 4 divided by 23, okay, 0.1739. So I would just simply answer this question in a quick sentence saying the proportion of crows that were classified as unhealthy is 0.1739. Yeah, that's as simple as it gets for question A. Question B, however, it says the mean level of the 23 crows has a sample mean of 4.9 parts per million. So there's my mean. It also gives me my standard deviation of 1.12 parts per million. So it says to construct and interpret a 95% confidence interval for the mean lead level across, or it says for the mean lead level of crows in the region. So it's a little bit hard for me to read. This is a little fuzzy, but I know you have it. So there's the mean. So I know I want to do a 95% confidence interval. So I'm going right to this whole 4-step process. So I'm sliding it over here. I'm going to kind of start over here at the top for B. State plan to conclude for this problem. So I always like to have this part here is we're going to start with the state. So we want to construct a 95% confidence interval for, now this is where you have to put it in the context of the problem. And so that's where I like to, just going to kind of slide down here, where it says, and this is the context right here. I'm basically using that piece. Okay? So for the true mean lead levels of crows in this region. All right, so that's my state. So I'm going to kind of switch colors as I go here. So now here comes the fun. Confidence interval. In the plan, there's really going to be 4 things I'm going to look for. Okay? First of all, I want to state type, what type of interval I want to construct. So I'm going to say we will construct a one sample, this is coming from a single sample, T confidence interval for a population mean. Okay? So I like to use those symbols. Now our conditions. Okay? So the first one that we want to talk about is it random? Okay, so yes, I like to say yes. We have a simple random sample of 23 crows. Then I talk about it being normal. Okay. In this case, okay, we are going to assume yes. And the reason why we are is n equals 23. Okay, so since it's not greater than or equal to 30, the central limit theorem doesn't apply. However, our stem plot, so this is where we look at the graph. So when I go back to this stem plot, it doesn't show any outliers and actually doesn't show any strong skewness at all. Okay? So I would say our stem plot shows, not shows, shows no outliers or extreme skewness. So we will assume our sampling distribution is approximately normal. All right, the last part is independent. Okay. So basically here, we are sampling without replacement. So we check. is the population greater than 10 times our sample. In our case, is our population greater than 230? And yes, there are at least 230 crows in this region. All right, so we got the state, we got the plan. Now we're going to do the do. So I'm going to do that in purple here. So now we actually have to calculate out the confidence interval. It's a confidence interval for a mean. So x bar plus or minus t star times the sample standard deviation over the square root of n. Okay. So now, one of the things we need to do is we need to get our t star score. Okay. So degrees of freedom, okay, is 23. Okay. And we have a 95% confidence interval. Okay. So we want to figure out what our t star is. So if I go to second vars and I look here, you'll have inverse t. Okay. So when you go to do the area, you can't put 0.95. You have to think about the area here, okay, as the middle 95. So remember, if I want to find this t star, this area here is 2.5%. So to get the correct t star score, I have to put 0.975. Degrees of freedom, 23. I'll paste that in there. That's going to give me my t star score. Oops, I apologize. Degrees of freedom is not 23. It's 23 minus 1, 22. Mr. Bartz, another small mistake here. So let me go back here. So I go second vars, inverse t, which is number 4. Gotta change that to degrees of freedom. I forgot to subtract 1. Wowzers. Glad I caught that one. So there we go. My t star is 2.074. Okay. So now, if you look in your book or whatnot, I don't think we handed out the t star distribution, unfortunately, to you, but this is also at the bottom of that formula sheet. Hopefully you've at least seen that pop up in the notes. All right, so now, remember from the information they actually gave us, here's our sample mean. So x bar in this particular case is 4.90 plus or minus, now my t star, 2.074. Sample standard deviation is 1.12 over the square root of how many crows we have, 23. So now, 4.90 plus or minus, I'm going to calculate this out of my calculator, 2.074 times 1.12 divided by the square root of 23. So I get 0.484. So now if I add and subtract that to it, okay, so 4.90 minus 0.484. Oops, I did the plus there. So I did the upper bound. 5.384. And 4.9 minus 0.484, sorry. That would be 4.416. All right, so the last part is our conclusion. So I'm going to just slide this up just a little bit. Maybe it will take it, maybe it won't. All right, there, it moved it up nicely for me. So we just say we are 95% confident that the interval, so is this is that fill in the blank statement, we are 95% confident that the interval from 4.416 parts per million and 5.384 parts per million captures, and then I go back on what I defined it as. Captures the true mean or mean lead levels of all crows in this region. All right, so that takes care of the first one. All right, let's take a look at the second one on the back side. So this one's very recent from the 2017 exam. I remember my kids taking this and kind of making fun of water cups. So number 2 here says the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup up with a soft drink from the beverage fountain instead of filling the cup with water. The manager selected a random sample of 80 customers, okay, so this is good to know, okay, who asked for a water cup when an order was found. 23 of those customers filled the cup with a soft drink from the beverage cup fountain. So here it says construct and interpret a 95% confidence interval for the proportion of all customers having asked for a water cup when placing an order will fill the cup with a soft drink from this beverage fountain. Okay? So just to let you know, in this problem, our p hat is going to be 23 out of 80. So just decimal wise, 23 divided by 80, okay, 0.2875 is going to be the p hat that I'm going to be using when doing this particular problem. So let's go through the 4 steps. So part A is just doing your 4 steps for a confidence interval, but this one is for a proportion. So we want to, oops, I got ahead of myself, to find a 95% confidence interval for the true proportion of customers, or of all customers. So, and then I kind of repeat the sentence, of all customers who, having asked for a water cup, fill the cup up with a soft drink. All right, so there's the state, the plan. All right, we will construct a 1 sample. Now that we're talking about a proportion, Z confidence interval for a population proportion. So I'm going to go through random, normal, and independent. So first of all, random, I need to note, yes, a simple random sample of 80 customers was taken. So now for normal, I like this one better. We need to check, is n times p hat greater than or equal to 10, and n times 1 minus p hat greater than or equal to 10. Well, in our particular case, we had 23 customers okay, who did that. So we had 23 that actually did take the soft drink. That means 57 did not. These two numbers will add up to the 80. Okay, and both check. So yes, that's good to go. And then, whoops, that's such a bad check there. All right, and then independent. Right. Again, we are sampling without replacement. So I'm going to check, is my population greater than 10 times 80? So is my population greater than 800? So we will assume there are at least 800 customers at this restaurant. All right. Whew. So now, random. So I've taken care of my conditions. So now I'm actually going to calculate out my interval. So my interval, p hat plus or minus z star times the square root of p hat 1 minus p hat over n. So what's nice is, remember p hat from up top was 0.2875. So 0.2875 plus or minus z star is a 95% confidence interval, 1.960. That's something that I just have in my brain memorized, but if you look at that T-star table, okay, if you look at the very bottom of it where it says confidence interval and go up where it says either infinity or z star, you'll know it's 1.960. Square root 2.2875. 1 minus that is 0.7125. Notice these two numbers will always add up to 1 over the number of customers in this case was 80. So 0.2875 plus or minus. So now I need to actually calculate this out. So I always start with the standard deviation part. I'm going to go with the square root of 0.2875 times 0.7125 divided by 80. So there's my that's my standard error. Got to multiply it by 1.960. That's going to be my margin of error. So I have a margin of error of 0.099. That's interesting, 992 if I go out 4 decimal places. Might as well. So if I add and subtract that to it, so 0.2875 minus 0.0992. My lower bound is 0.1883. And then my upper bound, 0.2875 plus 0.0992, 0.3867. So we can now interpret what this value actually means. We can say we are 95% confident the interval from 0.1883 to 0.3867 captures the true proportion of all customers who, having asked for a water cup, fill the cup up with a soft drink. All right, so that was just all of part A. Wow. All right, so let's finish up part B. B now says the manager estimates that each customer who asks for a water cup but fills it up with the soft drinks costs the restaurant 25 cents. Suppose that in 1 month of June, 3,000 customers asked for a water cup when placing an order. Use the confidence interval constructed in Part A to give an interval estimate for the cost to the restaurant for the month of June from the customers who asked for the water cup but fill the cup up with a soft drink. Okay? All right, so this is actually a pretty, I think, simple question to calculate out here. So sorry, I'm just trying to switch to a different color here. I'm going to move this up just a little bit. Let's see if it will move up for me. There we go. So for part B, if I think about this, my lower bound, I'm going to pull this down just so that you can see it, is based off the confidence interval, the proportion could be as low as 0.1183 and it could go as high as 0.3867. Okay. So now I'm going to multiply each of those by the number of customers. So that would give me the number of customers on the low side and the high side that are actually filling it up. Then I want to also then multiply it by how much it's costing me, 25 cents. So if I do that for both cases, so on the low side, 0.1883 times 3,000 times 25 cents is costing me, if I $141 and I can say 23 cents. Okay? And then if I do the high side, 0.3867 times 3,000 times 0.25. So on the high side, it's costing me about $290 and about 3 cents, okay, depending on how many decimal places. So I can then answer this question, a 95% confidence interval estimate for the cost to the restaurant in the month of June, so in June, is between 141.23 and 290.03. Now again, does your answer have to be exactly as mine? No, yours could be slightly different if you only went out 3 decimal places. All right, I hope this helped out.